In this video, I'll be solving trig equations. And before I show how to solve trig equations, let's just discuss the difference between what we do when we have an identity and what we do when we have an equation. So when we have an identity, what we want to do is we want to verify. In other words, we want to show that the left side is equal to the right side. When we have an equation, what we want to do is solve for the angle. Okay, so it's kind of like just when we're solving any algebraic equation, we want to find all the values that make the equation true. So here we want to solve for the angle that makes the equation true. So what we'll do here in this video is we'll do some pretty basic equations so that we can get the idea of how these work. Okay, so the first one says, find all solutions in the interval 0 to 2 pi. And our equation is sine of x is equal to 1. So before we start solving this, let's just talk about what some of this stuff means. This interval right here, 0 to 2 pi, because these endpoints are in radians, 2 pi is telling us this is in radians, we want our answer to be in radians. And what we're trying to do is we're trying to figure out what x is equal to. Now remember, the values that go into a trig function are angles. So x here is an angle. So what we're trying to do is find the angle that if we take sine of that angle, it is going to be equal to 1/2. And because the interval is telling us that we're between 0 and 2 pi, if we think about this on the unit circle, 0 to 2 pi, well, 0 starts here, and then we hit pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so we want to know, when does sine equal positive 1/2 in the first rotation or revolution around the circle? Well, sine is positive in quadrant 1 and quadrant 2, and sine is 1/2 at these positions. So that angle here is pi over 6. This angle here is 5 pi over 6. Okay? So the solutions, x is going to equal pi over 6 and 5 pi over 6, because sine of pi over 6 is equal to 1/2. Sine of 5 pi over 6 is also equal to 1/2. Okay? So another way we can think about this equation is by thinking about this question. Sine of what angle is equal to 1/2? And the answer to that question is pi over 6 and 5 pi over 6. So to solve this, it's kind of like we're taking the inverse, okay? It's kind of like saying sine inverse of 1/2 is equal to x. But we want to find all possible values. So the possible values we're going to say are x is equal to pi over 6 and 5 pi over 6. So that is our solution. All right, the next example says find all solutions in 0 to 2 pi. So again, we're in radians for the equation cosine of x is equal to negative root 3 over 2. Again, if we think about this on the unit circle, cosine is negative in quadrant 2 and quadrant 3. So cosine is negative root 3 over 2 at these two positions, and that angle is 5 pi over 6, 7 pi over 6. So we would say that x is equal to 5 pi over 6 and 7 pi over 6. All right, similar idea here. Tangent of x plus root 3 is equal to 0. Again, we're in radians. So what we want to do is we want to solve for the trig function. So we're going to say tangent of x is equal to negative square root of 3. So we want to know, when is tangent equal to negative square root of 3? Tangent is negative in quadrants 2 and quadrants 4. Okay, and it's at these positions. And those angles are 2 pi over 3 and, what is that, 5 pi over 3. So we're going to say x is equal to 2 pi over 3 and 5 pi over 3. One way we can check these, well, we check these just like we check any equation. We take the value that we solved for, and we substitute it in for the variable. Okay, so we can check 2 pi over 3. Well, tangent of 2 pi over 3 is equal to negative square root of 3, plus square root of 3 is equal to 0, and that checks. And we could do the same thing with 5 pi over 3. Similarly, on the previous two examples, we can take the values that we found as the answers, plug them in for the initial or the variable, and see if the left side is equal to the right side. All right, and then in this one, the only thing different is that this interval is in degrees. So we want to find angles that are in degrees. And now this is saying, when is sine equal to 1? In other words, sine of what angle is a value of 1? So if we think about this on the unit circle, sine is equal to 1 at this position, and that's pi over 2. However, we want to be in degrees, so that's the same thing as 90 degrees. Okay, so there's only one solution to this equation, and it's 90 degrees. So we'd say x is equal to 90 degrees here. And that's it. So for this one, again, we're in degrees. And we want to know when cosine of x is equal to 0.3. In other words, what angle has a cosine value of 0.3. Now, the issue here is that 0.3 is not one of the values on the unit circle. Okay, so if we look at the unit circle, cosine 0.3, well, I don't know exactly where that is on the unit circle, but what I do know is that 0.3 is positive, and cosine is positive in quadrants 1 and quadrants 4. So I don't know where in quadrant 1 and quadrant 4, but it's maybe something like that. Now, because 0.3 is not on the unit circle, we're going to use a calculator. And what we're going to input is cosine inverse of 0.3. And what we get is 72.54 degrees about. So this angle, 72.54 degrees. And really, this angle is going to be more like up here. Okay? And one thing to remember when we're using the calculator is that we are in degree mode. Okay? All right, so the calculator only gives us one of these values. It only gives us the value in quadrant 1. We need to figure out what the value in quadrant 4 is. Now, there's a couple ways you can do this. One way is to think about the reference angle. The reference angle here is 72.54 degrees. So what that means is this reference angle is also 72.54 degrees. So to figure out the other value for x and what this angle is right here, what we can do is 360 degrees minus the reference angle, and that'll give us the other value. And we get 287 point, let's call it 46 degrees. Okay, so when it's all said and done, the two angles are 72.54 degrees and 287.56 degrees. Okay, so a couple things to check. We could input each of these x values into the original equation to see if we get cosine of those angles equal to 0.3. A quick check also is just to think, well, 0.3 is positive, cosine is positive in quadrant 1 and 4, and the two angles that we found are, the first one is in quadrant 1, the second one is in quadrant 4. So that just kind of verifies that we're in the right place here. All right, and then the last example for this video, we want to find the solutions in 0 to 2 pi. So again, that's in radians. For this equation, 2 sine of x minus pi over 4 plus 1 is equal to 2. So the first thing we want to do is isolate the trig function. Okay, so we want to solve for this first. Okay, so I'm going to subtract 1 and then divide by 2. So sine of x minus pi over 4. I'm subtracting 1 and then dividing by 2, so I end up with 1/2. At this point, we have sine of x minus pi over 4 is equal to 1/2. What we want to ask ourselves is, what angle has a sine value of 1/2? Okay, so we don't, inside the argument here, even though it's x minus pi over 4, we don't even need to consider that yet. We really just want to know sine and 1/2, what angle has a sine value equal to 1/2. So again, on the unit circle, sine is positive in quadrant 1 and 4. Sine is 1/2 here and here. We want radians, so pi over 6, 5 pi over 6. So what we do here, because we have those two values, and inside the argument, we don't just have x, what we do is we branch this off into two separate equations. X minus pi over 4 is equal to pi over 6, and x minus pi over 4 is equal to 5 pi over 6. And so from there, we just solve each of these little equations. So I'm going to add pi over 4 to both sides. And getting a common denominator, pi over 6 is 2 pi over 12. Pi over 4 is 3 pi over 12. So we end up with 5 pi over 12 for our first answer. And then x is going to be equal to 3 pi over 12 plus 10 pi over 12. And that gives us 13 pi over 12. As our other solution. And again, we could input both of these values into our original equation to see if the left side is equal to the right side.